which is the same as taking their average, right? That's how we do averages. We add things up and divide by how many there were. Give me any two distinct numbers. I can always find the one in the middle of them by taking their average. So no matter what you do, if you try and find me a number right next to 1, I'll always take it, add it to 1, divide by 2, and I'll have a number right in the middle of those. And so then you say, okay, well that new one's the one that's closest. Well, then I do it again. And I can do that forever. And so there is no number closest. It's kind of like this question. I remember I was in elementary school. I can't remember. Maybe it was middle school. My science teacher had this question. If I start on one side of the room and I walk halfway to the other side, and then I walk halfway again, and then halfway, and then halfway, and then halfway, will I ever reach the other side of the room? Is there always halfway between 2 points? Yeah. There's always halfway, theoretically. I mean, you do get to a point where we're talking about atoms, but theoretically, you would never get to the other side of the room unless you could keep going forever, which you can't do that forever. So, yeah. So this whole idea is weird, and this is where calculus is going to take you. Okay, calculus is going to start talking about things that are done infinitely many times, infinite processes as opposed to finite processes. But you're still, this class in pre-cal away from calculus, so. All right, hope that settles that. Okay, next thing I keep putting that right in the same spot. Y'all doing okay online? They're asleep. We have margarita machine here. We have margarita machine in the back of the room, so don't try and make us feel jealous. Okay, next thing we want to talk about when it comes to graphs is something like this. You know what? Let me do that again. I don't like the way that looks. Let me just do this. It's not perfect. Is that a function? Yes, okay, that is a function. That function has a special kind of property when you look at it. It should kind of like jump out at you and be like, there's something like, it looks very even, right? What's that? It's like a mirror image of itself, right? And that's called symmetry, all right? Symmetry. So this function would be symmetric to the y-axis. In other words, if you look at the y-axis, that's this. If you were to take this side and reflect it over, you would land right on top of the other side, right? And that's called y-axis symmetry. Now, is it possible to have x-axis symmetry? Well, I could draw something that has x-axis symmetry. I could draw it. Here it is. I mean, sorry, it's not great. That's really bad, actually. Let me try this again. I haven't drawn on a board in like over a year, so there we go. So is this symmetric to the y-axis? I mean, to the x-axis? It is, right? Now, is it a function? It's not a function, but we can still talk about symmetry. This is symmetric to the x-axis. Let me give you one more. Is that symmetric to the y-axis? If I flip it over the y, is it going to land on itself? No. How about symmetric to the x-axis? No. You said something, though.
Y equals x. The line.
Y equals x? What about it?
It's symmetric to that line.
Oh, it looks like if you draw a diagonal, it would be symmetric to that diagonal? Yeah. I agree. And when we talk about inverses, I'm going to bring that up again. I'm not disagreeing, but yes. Okay. Were you going to say something also or no? Yeah. Same thing? Okay. So this is not y-axis symmetry, right? It is not x-axis symmetry. But imagine that you did this. You had this symmetry and this symmetry put together. So what if I asked you to first reflect this over the y-axis? Okay, what would you get if it reflected over the y-axis? This goes over here, right? So that would become that. And then this one would come this way, right? And become that. That would be y-axis symmetry if we had that. Now reflect that over the x-axis, and what would you have? It would land on top of itself, wouldn't it? So even though this blue one is not y-axis symmetry, it's not x-axis symmetry, it's kind of like a double symmetry. It's y followed by x. It's called being symmetric to the origin. That's what it's called. So symmetric to the origin. I didn't make it up. X-axis symmetry makes sense. Y-axis symmetry makes sense. Symmetric to the origin, not sure if that makes sense, but it's like a double reflection. You can do around y then x, or you could do x then y. It works both ways. Is that a function? The blue one was a function, right? Okay. Now, what are some properties of symmetry? This is a super important idea. What are we doing on time here? Okay. So let's go back to this one. There's something really important about y-axis symmetry. If you were to take, let's say you had a function that has symmetry to the y-axis. If I were to pick some arbitrary value of x here, right? It's going to spit out some value up here, right? This is going to be what it is, whatever that is, yes? That y value also appears over here, right? These have the same height, don't they? And can you tell me what x value that would have to come from then?
The opposite.
The opposite of what this one was, right? So if this was x, this would be the opposite of it, which is negative x, right? So which means that anytime you have y-axis symmetry, you have this equation. That if you plug negative x into the function, you get the same as plugging positive x into the function. That is an important property of y-axis symmetry. So if you were to plug in 2, that answer would be the same as plugging in negative 2. If you were to plug in 3, it would be the same answer as plugging in negative 3. This is also known as, does anyone know what that is also known as? When a function has that property, we say something about the function. We say the function is even. It's an even function. Now, I will address that again a little bit more later, but in case you've heard that in the past, that's what it means for a function to be even. Yes?
It's odd that negative would be in front of f, right?
Yeah, that would be this. If it was this equals that, but a negative in front.
Okay.
Guess what? Guess which one of those that is, though? So this isn't a function, remember, right?
Yeah.
So it's got to be this one, right? So let's see. Can you all wrap your heads around this? If I plug in, go to this function right here. If I plug in x, right? If I plug in x, I'm going to get some y value out, right? Whatever that height is, what am I going to get if I plug in negative x? So go here and go to the other side to negative x. It's going to spit out this point, right? Are these the same? How are they different? This one is positive and that one is negative. So what we could say is this. If you plug x into the function, you're going to get some value out, right? That's this. That's the height. That should be equal to what you get when you plug in negative x. But they're not the same, right? You just said this one's positive, that one's negative, right? So just put a negative in front of this, right? Yes?
Can't we also tell that it's even or odd by the way the arrows face? Like if they both face the same way, it's even, and different directions is odd.
Kind of. To say it's even, we need the y-axis symmetry.
Oh, okay.
So if you just have, like if I drew this, that's not even. Because now both the arrows go down, but it's not symmetric to the y-axis. You have to have the symmetry, the y-axis symmetry, to say it's an even function. Okay? And then same with this. If the arrows are opposite, that doesn't mean it's odd. You would need the origin symmetry. So this is the equation we have. Now this is not the way it appears in textbooks. What textbooks do is they multiply both sides by -1. So they put a negative here, make that a positive. And that's what we mean when we say that a function is odd. Even functions have this property. Odd functions have this property.
It doesn't change anything if it's shifted to the right or left, right?
What do you mean?
Like, it goes, I don't know what to say.
If you translated this whole function left or right, yeah, you throw away, the symmetry goes away, right? So if I just take this whole function, just slide it to the right a little bit, that's all gone. Symmetry's gone, it's no longer an even function.
What would it be then?
Well, it would just be some other function. So in general, all right, in general, the idea of even and odd is not one or the other. If I hand you a function, you can be even, it could be an even function, an odd function, or neither. Okay? Neither is an option also. So this would be a function that's neither even nor odd. So moving this a little bit to the right, boom, you're no longer even or odd. Now what if I move it just up or down? Do you lose the symmetry? No. You don't, right? So if you moved it up or down, you'd still keep this. This one, same thing. If I move it left or right, I'm going to lose the symmetry, right? What if I move it up or down? I'm going to lose it, right? I'm going to lose it. Okay. How are we doing here? 20 minutes? I'm gonna make sure I tell my wife tonight how much I respect what she does for a living. She's in the medical field, so she double masks and wears face guards for big old long shifts in the hospital. This sucks. I haven't had to wear a mask for this long ever. This kind of sucks. All right, here we go. This is going to be a little bit different. I'm going to give you a function. First question. Yes.
Is there no formula for the X-axis symmetry?
Well, the X-axis symmetry, anytime you have X-axis symmetry, you don't have a function, right? Because it fails the vertical line test. So it wouldn't make a whole lot of sense for me to say f of something equals f of something, because it's not, you can't even call it f of something because it's not a function. That make sense? Now you could do it in a different way, but you would have to change how you're looking at it. You would have to look at it as a function of y instead of x.
Wouldn't with the x-axis symmetry, isn't that used a lot with quadratics and parabola?
For the parabolas that open sideways, yes. Yep.
So
Yeah.
what will we label it as? Will we ever come across problems with the
When we look at parabolas, anytime in conic sections, then we will look at symmetry in that axis, but we won't be looking at them as functions, the way that we are traditionally looking at f of x equals something. We're not going to be doing that with things that go sideways. All of calculus, pretty much until you get to Cal 2, is traditional good old functions of x. And then in Cal 2, at some point, you do have to start looking sideways and looking at as functions of y. But I'll talk a little bit about it, but I think stay tuned. Yeah. Okay, is this point on the graph? First question. So is -1, 5 on the graph? So this is what we were talking about earlier, right? Like, what do I mean by this? Do I mean this is an interval or a point? What do y'all think? Point, right? So I'm saying if you plug this in for x, is this what comes out? No, right? What happens when you plug in, if you try and plug in -1 here, what happens? You get -8 over 5, right? You get -8 over 5 if you plug in -1. And that's definitely not -5. So the answer is no. It's not on here. Right? Next question. Find f of 3. Okay, so I just want you to plug 3 into this, right? That's it. Just plug in 3. So what would we get? On top, what would you have? -4. And on the bottom? 9. And that's it. We'll just leave it. It doesn't reduce. Let's not get a decimal. Let's just leave it like that. Okay, next question, C. If f of x equals 4, find x. So part B is easy. I ask you to plug 3 in, you plug it in, it spits out an answer. Part C is saying, hey, look, the function needs to spit out the value of 4. Tell me what x you have to plug in to get it to spit out 4. So how would we do this? Here we just replaced x with 3, right? But how do we do this?
4 equals x minus 7 over x plus 6.
That scared me. For a second, thank you. I thought, for some reason, I thought like Alexa had changed her voice. I was like, did Google Assistant just answer? Or is Siri? Oh man, that was funny. Okay, so say again.
4, you would put 4 equals x minus 7 over x plus 6.
Yeah, we're wanting to know when is the function equal to 4, right? So we're going to take the function and we're going to set it equal to 4. So we're going to take that entire expression. That'll be funny for me to go back and look at. Okay, we're taking the function and setting it equal to 4. And then we have the task of trying to solve for x, right? And so how would y'all go about solving this for x? Multiply both sides by x plus 6. So what you're doing there is you're clearing the fractions out, right? You're going to get these fractions out of here. So you multiply by x plus 6 here, x plus 6 here. Gone, gone. You get x minus 7 equals, now here on the right side, you distribute, right? So you get 4x plus 6. And now that's just a linear equation, right? You should be able to just get all your x's to one side and then move all your non-x's to the other, right? So, oh, did I forget 24? Yes, thank you, thank you. I know what you're saying now. 4x plus 24. So move, let's get, I'm going to leave the x's on the right side. So I'll subtract x on both sides. That gives me 3x. Then I'll subtract 24 on both sides, and that'll give me, what, negative 31?
Yeah.
And then divide both sides by 3. So x is some fraction here. Negative 31 over 3. I'll just leave it like that. Okay, I'm not going to get a decimal on my calculator. I'm just going to leave that as a fractional answer. How are we doing here? Okay, 12 minutes. Still have quite a few more things to ask you about. Let's C, D. Okay. Next thing, find the x-intercept. I'm going to say x-int ints. There might be more than one x-intercept. So I want you to find out where they are. So I'm saying if you were to graph this, where would this thing hit the x-axis? Now earlier, remember I had asked y'all, what does this question really mean? And someone said, oh, it means find the x-intercepts, right? What is it that we always do? And this will be the case through all calculus and everything, you know, a lot of math that you do. How do we find the x-intercepts for any function? Not plug 0 in here. That's actually finding the y-intercepts. Anytime you want to find the x-intercepts, you always take this, set it to 0. Okay? Set the function equal to 0 all the time. So to do this, you set the function equal to 0. So we're basically saying, where does the output give you a 0, right? When does 0 come out of this? That's what we need to solve. Now, I'm going to say this, and I'm going to say it several times. This will help you a lot in calculus, all right? Anytime you ever have a fraction being set equal to 0, you can ignore the denominator completely and just ask yourself when the numerator is 0. Say it again. Anytime a fraction is equal to 0, you can completely ignore the denominator and just set the numerator equal to 0. All right? Anytime you have a fraction set equal to 0, you can ignore the denominator and just set the top equal to 0. That's 3 times I told you that. Now, the reason why is pretty simple. Because anytime I would ever have a fraction, let's just say I had that equals 0, right? Some fraction equals 0. Doesn't matter what the fraction is. I could always multiply by b on both sides. The b will always go away, and 0 times b will always be 0. So I really only care about when the top is 0. Okay? So I'm going to ignore this, and I'm just going to solve that equation. X minus 7 equals 0. And so x must be 7. So if you were to graph this function, right, if you were to graph it, you would go out to 7, and there would be an x-intercept there, for sure. Right, let me ask about the y-intercept. Find the y-intercept. So now this is where you just plug 0 into the function. So this would be where the graph hits the y-axis, right? This would be where the graph hits the y-axis. Could we have more than one? Think about the y-axis. Oh, look, let's say that's your y-axis, right? What if we could, x-intercepts. Could we have more than one x-intercept? Yeah. Absolutely. Could you have more than one y? Then you wouldn't have a function, right? So as long as we're talking about a function, you should not have more than one, a function of x. So we should only have one here. So just plug 0 into there, and you get negative 7 over 6. And you're done. Okay, 8 minutes. 2 more questions. The first one's going to be somewhat easy. Second one's going to be harder. F. What's the domain of this function? So we talked a little bit about this last time. You look at the function. Is there anything you cannot plug into that function? Negative 6. That's it, right? That's the only thing you can't plug in. Negative 6. Can you plug in 7? Yes. Yeah, because you can have 0 on top, right? You just can't have 0 on the bottom. Yes? It would be division by 0, right? We would have 0 on the bottom, which we can't have. So the domain of f is basically all x's such that x is not equal to -6. Or in interval notation, -infinity to -6, don't include it, -6 on to infinity. Everything except -6. That's the shorter way of saying the same thing. That's your domain. Okay. G. This one's the hard one. What's the range of this function? Normally, yeah, okay, I'll just do that. Ran. You can do that. Ran f. This one's harder, okay? Because you're trying to figure out what outputs this could have. What do all the outputs look like? And it's very, in general, okay? In general, everybody, it is difficult to find the range of functions, in general. It's not an easy task. So I'm going to actually leave this as an open question, because we will have a way to do it later. But just a visual inspection is not really easy to do on a function like that. So I'm just going to leave this open, all right? I just want to point out that it's hard to do in general. Okay, I think I've gotten through everything I wanted to get through. Let me just double check some things here. I think you have what you need to do the homework. Yep. I think most of the main ideas are there. Are there any questions? Oh, wait, there was one of these. We'll see how that goes. I'll let y'all figure out that one on your own. That'll be interesting to see what you do there. Any questions about anything?
Which homework is that?
So I extended the 3.1 homework to be due on, I believe, wait, 3.1? This was 3.2. So 3.1 is due on the 13th, I believe, which is Monday. I'll have to double check. I think 13th is Monday. So you should, by Monday, you should do 13.1 and 13.2. Because we are now done with those sections. We're still, this is due Monday. We're still a section behind, okay, but we've now covered the material for those two. And I'm going to do my best, like I said, to try and get that homework solution videos up. But my priority is getting a laptop that works. So, yeah. Well, just walk across and see. I'm not sure what their hours are. I think they have something posted here, but they should be able to at least tell you when they're available. Yeah. So I hope this worked out. I'm going to continue, like I said, doing this Zoom thing. If you decide that you want to hang out at home and not be here, that's okay, but you have to be here for the test, at least for the first one. Okay. All right, Lorena and Desiree, y'all good? All right.
Yes.
Okay.
Yeah.
Any questions?
No.
No. See, they just get to click and go back to life now. But we're having margaritas. All right, we'll see y'all later.
Thank you.
All right, bye. Okay, thank you all for being here. I'll hang out for a minute while I'm packing stuff up if you have any questions. Let's see, we're going here.
This is college algebra, right?
Yes?
So what's next from this semester?
Pre-calc, what's next after this class? Or what's next in this class?
College algebra.
Then you do pre-calculus, and then that would let you feed into Cal 1. Did you do that in high school or something, or how far did you go in high school?
I did calculus AP senior.
So why are you in this class?
I don't know, probably because I didn't pass the AP test.
That shouldn't put you here, though.
I mean,
You did AP Cal 1 in high school.
I did junior.
Uh-huh.
I did pre-cal on-ramps for UT.
Yeah. How did that go?
I
passed the class, but I rejected the credit.
Okay.
It was like a 70 or something like that.
Yeah.
I just didn't like it.
Yeah.
And then as a senior, I took calculus 18. But I didn't pass the test, and I was wondering what.
So did you take a test to get in here? So you should at least at a minimum be in pre-cal.
Because I tried calling my advisor, but she never answered, and the guy that helped me pick my classes, he told me I had to take this in place.
It's probably maybe because you don't have an actual college credit. What the hell?
And my advisor just doesn't answer the phone.
Well, that's not good for you, because this is obviously material that you're just like, you know. It's not too late to talk to an advisor. I know there's not much I can do to help you on that end, but you might want to talk to them and just be like, you know, would you rather be in at least like pre-cal? Where,
If I can do the class, which is
the thing is, you probably don't have a college credit for algebra. That's probably why they told you have to do this class. You don't have a college credit for algebra. That's my guess as to why they